Alright, so now let's look at the day 2 part section in your notes for implicit differentiation. Okay, so find the derivative dy dx in terms of x and y. So just like we've been doing, I want to get my answer in terms of x and y, and we're going to take it in respect to x. And it's saying at the given point. So I'm given an actual xy value with a point. So this is an xy coordinate point, and we're going to plug that into our derivative after we get dy dx. So immediately you should look at this and see product rules. So the first times the derivative of the second, again this is dy dx because we are in respect to x, and it's going to be plus the second times the derivative of the first, which is an understood 1. Okay, so this is equal to 0 because the derivative of a constant is 0, and then now move stuff over to get your dy dx alone. So we have dy dx is equal to, again, these positive signs are separating our monomial terms. So here's a monomial, here's a monomial. We know this is a positive y over here on the left side, so I'll move it as a negative y to the right side. And then finally divide by x. So dy over dx is going to be a negative y over x. When I plug the values in, I'm going to borrow this negative 1 right here, put it in for x, and then I'm going to borrow this negative 9, I'm going to put it in for y. So be careful when you plug in that negative 9, because it is actually going to be a negative 9, okay? Because you're only plugging it in for y, so you have this negative to further account for, and then you have it over a negative 1. So you should get a positive 9 over a negative 1, which of course is dy dx, or y prime, however you want to write it, is equal to a negative 9. Alright, and let's go ahead and move on. We're done with that one. Find the second derivative. Okay, so this is the notation. When you're doing dy dx notation, that will tell you what level of derivative you want to find. So if I want to, let's say, f triple prime of x, it would be 3, and then it would be 3 down here. Okay, there's no special reason why the 3 is here with the d, and then it's there for the x. That's just the notation that was chosen when Leibniz was doing dy dx. Okay, so, and Leibniz being the German, aside from Isaac Newton, that invented calculus. So looking at this, dy dx is going to be f triple prime if it's written like this, or triple prime if it's written like this. So we are asked to find the second derivative. Okay, so the second derivative, we're going to go ahead and interpret that as f double prime of x. And we're going to do it implicitly because I have the formula or the function where I can't solve for y by itself. So here we go, 2y y prime, or dy dx, plus product rule is first times the derivative of the second plus the second times the derivative of the first, the understood 1. Notice my use of parentheses yet again, because this positive, if it were negative, would distribute and affect this term right here. Okay, so just for good habit and good practice, I'll put parentheses there. Is equal to 0 because the derivative of 25 is 0. Okay, so I'll count my monomials that are separated from those addition signs, and I see that the y is going to move over and the dy dx is going to factor out on the left. So I'm left with 2y plus x is equal to a negative y. So when I move it over, I have dy dx is equal to negative y over 2y plus x. And that should be my answer because I'm wanting to write it in terms of x and y. That's my answer for the first derivative, that is. Okay? So I'm going to go ahead and write that off to the side. So if you need to rewind this video in order to see this work again, you're more than welcome to. But I'm going to go ahead and start on the second derivative. Okay? So the second derivative, I'm just going to take what my answer is right now, and I'm going to derive it again. And I'm going to use quotient rule to take the derivative of this. So the second derivative is equal to low d high is going to be a negative dy dx minus high, and then d low is going to be 2 dy dx plus 1. Again, because you are in respect to x. Notice my use of parentheses, otherwise things would be wrong when you're inputting them into either WebAssign or writing them on the piece of paper as far as what distributes and what doesn't. So it's over low squared. right now, this could be the answer, but you would get part of it wrong because of the fact that you don't have it written in terms of x and y. You have it written in terms of x, y, 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 x, but you also have it written in terms of dy dx. And it didn't say to write it in terms of dy dx, it said just x and y. So we need to figure out a way to resubstitute all this where the dy dx's are at, because then, and at that point, it would be in terms of y and x. Now, this is good algebra practice because you're about to see the algebra that you're about to do with these problems, and I'm going to go ahead and substitute those in right now. So we have, let me go ahead and just erase, no, I'll just rewrite it. 2y plus x, and then written in with this, notice this dy dx is this entire thing here. So this negative is going to cause it to become a positive because of the fact that this negative times this negative makes it a positive. So it'd be y over 2y plus x minus, again, that negative y. Here's that other negative that's going to make this negative again right here become positive. So I'm going to put positive y over 2y plus x, and it's going to be, hold on, I just realized something. Just caught my mistake before I get the emails. That's not going to be substituted in for y. It's going to be substituted in for dy dx. So don't substitute it in there. Don't do that. Just write the negative y as is. And then it'll be 2 times negative y over 2y plus x. That's where you're going to substitute it in. Plus 1 all over 2y plus x squared. Okay, so you just recap. I've substituted my dy dx in only for the dy dx terms. That negative right here became a positive because of the fact that it's multiplying with this negative. And everything else looks good right now as far as what I've substituted in. So technically, if this was a web-assigned problem, yes, you could get full credit and full answer right here, and it would not give you the red X. But what we're going to do from here is we're going to simplify all this so that you can see what you'll be held accountable algebraic-wise here very soon. All right, so let me minimize all this stuff real quick. And here we go. The first thing that I would say for you to identify is this entire piece that follows the subtraction. And I'm saying the subtraction right here. So I would group all this together, and from what you see here, this parentheses is very important that I forgot to write right there, because this negative y would distribute across to that positive 1. So what I want to do now is simplify stuff and distribute that so I can get common denominators. So negative y and negative y are going to become a positive y. So I'll get the positive y, and it's going to be 2, and it'll be 2y plus x. And then that negative y is going to distribute all the way to that positive 1, so that I get a negative y like that. So all I've done is distribute this negative y across each term because of these two parentheses here. Okay? I still have this negative to contend with that I haven't yet used, and when I distribute it, that first term would be negative and the second term would be positive. So let me go ahead and change those right now so that you don't have to see it with parentheses. Okay? Now what I'll do is these two combine because they cancel each other out because you're multiplying by this and dividing. So that's a form of 1. So that you'll have y left over, and then you have 2y plus x squared on the bottom. So far this is our simplified answer. Okay, so I have a y down here, and then I have another plus y. So I can go ahead and combine it right now to say 2y minus 2y over 2y plus x all over 2y plus x quantity squared. From here you should see I need a common denominator in the numerator part. So I'm going to multiply it by a form of 1 right here. And it will be 2y plus x over 2y plus x. So now I have common denominators in that numerator piece. Of course, 2y and 2y plus x will distribute here so that I get, let's see, 4y squared plus 2xy. And then it's going to be minus 2y all over 2y plus x. That's that common denominator that you see here and here. And then all over the 2y plus x squared. Now you should know by now that's the same as bringing that up and multiplying it together so that you have it to the power of 3. And most likely this would be the way that I would want you to write your final answer in a form similar to this right here. So you'd have 2y plus x raised to the third power on the denominator, and you could say that this is the second derivative. Okay? If you wanted to simplify it even further, you could, but basically what I'm trying to show you is this form of 1 that we got as far as common denominator in this whole numerator part, so that you can ultimately get it to a prettier fraction to where it's not something that's as involved as that, where you have 3 levels of fraction basically. Okay? So let's move on to the next example. Again, we're taking the second derivative. So here's my implicit differentiation, the function there that I'm going to go and start with. I have 0. This negative right here, I would constant multiple rule that out and then do product rule between x and y. So we have first times the derivative of the second plus the second times the derivative of the first, which is just 1. I will put parentheses yet again because now this negative does distribute. Okay? And then it's equal to 1 minus dy dx. Okay? So looking at this, I have negative x dy dx. Then I have minus y is equal to 1 minus dy dx. Combining the dy dx's together, I could move this to the left side of the equal sign by adding it. So I would have positive dy dx minus x dy dx. I'm also going to move over this y by adding it to the right side. So I'd have equal to 1 plus y. After factoring out dy dx, I would have 1 minus x. And again, that 1 coefficient is what that understood coefficient is for that term there. And I would have it 1 plus y, so that dy dx, all by itself, the first derivative is 1 plus y over 1 minus x. Okay? Now I'm going to do this one more time because I want to do the second derivative. And again, that notation is from what I showed you from before, is right here as far as there's the second derivative that we're trying to find. Okay, so there's another quotient rule. So it's going to be low. So the second derivative is low d high is 0 plus dy dx. So low d high minus high, and then d low would be a negative 1 because of that coefficient right there, and all over low low. So it's going to be that squared. Okay? Okay, so from here, let's simplify some stuff. First of all, I can't leave my answer like that because of this dy dx. I'm only writing it in terms of x and y. So I'm going to plug all this back in for dy dx. So we have 1 minus x. Then my plugging in is 1 plus y over 1 minus x minus 1 plus y times a negative 1. So this negative 1, I can go ahead and change this negative 1 right now to distribute so that it's really adding this 1 plus y. Okay? And it's all over 1 minus x squared. So all I need to do is just simplify this piece. You should see right there they multiply to a form of 1 as well, so that the top ends up becoming 1 plus y, and it's going to be plus another 1 plus y. Oops. And it's all over 1 minus x quantity squared. So you could see that combined like terms, and then you would get 2 plus 2y over 1 minus x quantity squared, and this would be your answer for the second derivative. Okay? Now let's move on. Consider the curve. This is not a function because obviously it fails a vertical line test, but we're trying to find the derivative as far as the dy dx. Okay? So looking at my equation here, I'm going to go ahead and start doing implicit differentiation and get 3y squared dy dx plus 2y dy dx minus 5 dy dx. And again, that's not just 5 because it's in respect to x. This has to be 5 dy dx. And then minus 2x is equal to 0. And my goal is to get this y prime, this y prime or dy dx term all by itself. So you should see the only one that I'm going to move over is this 2x, and then everything else is going to be like a coefficient. So dy dx, 3y squared plus 2y minus 5, and the 2x is going to be moved over because I'm going to add. So there, finally, my answer is going to be dy dx is equal to 2x over this entire 3y squared plus 2y minus 5 piece. Okay, so there's the answer for part A. Now we're going to write an equation to the tangent line with x and with y. Oops. So the y was -3. I'm going to put that there, and then of course the x, I'm going to put it right here. Hence, that's why we write it in terms of x and y. So the top will be 2, and the bottom will be -3 squared is a positive 9, so 27 minus 6 minus 5. And that's just from plugging in the numbers. That'll be my derivative, basically my f prime of 1, saying that it's the derivative there whenever the x value is 1. Okay? Otherwise, what we're doing here is just like the calculator notation is the derivative of the function of whatever the function is. We could just say that it's f of x, and it's evaluated at x is equal to 1. That's another way to look at it as far as the calculator. So 27 minus 6 is 21. Minus 5 more is going to be 16. So you have 2 over 16. So you have a 1 over 8 is your slope. So that's the slope at that 1, -3 point. So 1 over 8, I'm going to go ahead and do the point slope formula. It'll be y minus y1. So y minus a -3 is equal to 1/8. And it's going to be x minus x1. And that would be your answer. You don't have to simplify it if you don't want to. But if you did, it'd be y is equal to 1/8 x minus 25 over 8. Okay? So, next part. Next part wants to know, find the coordinates of the points where the line tangent to the curve is vertical. So we're talking about here, where it's vertical, here, where it's vertical, so on and so forth. And this is a key word that you should be thinking. That's where the tangent is vertical means the slope, or f prime of x, is undefined. It's not 0, because f prime of x, or the derivative when it's 0, that's when we have a horizontal line. Undefined is when it fails its own vertical line test, so it would be a vertical line. So what we're going to do is we're going to find, first of all, we're going to go back and we're going to set our derivative equal to undefined. So let's go back and write our derivative that we had from part A. So we have 2x, so let me go ahead and write that, y prime, or dy dx, is equal to 2x over 3y squared plus 2y minus 5. And that's what we got from part A, right here. To get this to be a vertical, otherwise undefined slope, we need to set the denominator equal to 0, because that's what will make this undefined. Okay, remember the top is 0, the bottom is a number other than 0, that would be a 0 slope. That's what we only have to set the top equal to when we're wanting to find the horizontal. But when we set the bottom equal to 0, it doesn't matter what the top is, 0 or not, this is going to yield an undefined slope. So that's why, again, that's why we're doing the bottom one equal to 0. Okay, so let's set the bottom one equal to 0 and solve for y. So we have the following. And from here, now it's been a while, you can use a calculator or you can use synthetic division, whatever you need to do in order to find these. Chances are that this one might be a calculator problem because of the complexity of these numbers and how they fit. You're not going to get a pretty answer. So what you would do is you would do the solve feature. So solve feature 3y squared plus 2y minus 5 is equal to 0. And you do comma y. And when you do that, you're going to get y is equal to -5/3 or a +1. So -5/3 is y, Let me go ahead and do that in the calculator actually. Let me go ahead and show you that. So menu 3(1), it's going to be when y cubed, so y cubed plus, let me make sure that I'm doing this right, 3y squared, what am I doing y cubed for? So let me go back, 3y squared plus 2y minus 5. So 3y squared minus 2y minus 5 set equal to 0. We do comma y, and then we go ahead and control answer. So I have a -1 or a 1.6667. So let me go ahead and do that. Y is equal to -1, or y is equal to this 1.667, and that is the same as -5/3. Okay, so -5/3 is the same as that decimal answer that you had. These y values are what would make the bottom undefined. Okay, so when we're looking at that, when they make it undefined, what we're going to do is we're going to use these to see what would the x values be. Okay, so we're going to plug in this y value here and here and here, and then solve for this x. That'll give me what these points are. So let me go ahead and plug in -1 right here. So we have -1 cubed is -1, plus 1 plus 5 minus x squared is equal to -4. So moving stuff around, I have -1 plus 1, that's 0. Then I have 5. I'm going to move the 4 over, so I have 9. And then I have x squared. So x is equal to plus or minus 3. So plus or minus 3 is what you're going to get for x. Let me make sure that I did that correctly. It might be a little bit off. Let me make sure. Okay, I figured out where I have a problem. When I looked in the calculator, I might be going a little bit too fast. Let me erase something real quick, not too far back. This right here should have been, so real quick, I'm going to go to the calculator. What I made a mistake on, I'm glad I caught it, is that plus 2y. So the plus 2y, when I put it in the calculator, I didn't put plus 2y, I put minus 2y, and that's why it wasn't working out. I knew something was wrong, something was up. So we have a, there we go. We have a -5/3 and a +1. There we go. So -5/3 and y is equal to 1. Now it's going to work. So these are correct now. So plugging them in, I have 1 plus 1 minus 5 minus x squared is equal to -4. So we have 2 minus 5 is -3. Moving that over, or just let's say -3 minus x squared is equal to -4. We add that over, so we get 1 is equal to x squared. And therefore, we have x is equal to root plus or minus of 1. So we know that's going to be plus or minus 1. So x is equal to plus or minus 1. So this plus or minus 1 stems from when y is equal to 1. So those points are +1, 1, and then -1, 1. Again, these are the x values here that you get from this plus or minus, and this y value of 1 is going to be right here and here. So I've created 2 points, 2 coordinate points from this y value of 1, and you see them right here, -1, 1, and +1, 1. Okay, so you do the same thing, plugging these -5/3 and all these y values, and you can use the calculator to do the solve feature. When you solve for those, you should get x's equal to 3.238 and a negative, so plus and minus 3.238. So those points become 3.238 and a -5/3, and then a negative 3.238 and a -5/3. And those 2 points would be here and right here. Okay? So, my answer is the final coordinate points on the curve where it's vertical will be these two right here and these two right there. Alright, 3 more problems and then we are done with this video. Looking at these 3 problems, we are reinforcing the idea of the definition of the derivative. And that is y2 minus y1 over x2 minus x1 as h is approaching 0. So I'm basically wanting you to interpret this as y2 and y1. The one that's most important is this f of x, because I'm going to show you a shortcut on how you can solve these out using that f of x. So if I looked at this and I said this is f of x, I could go ahead and say f of x is equal to 2x cubed. Okay? So that if I asked, this is the definition of the derivative, all this right here is equal to f prime of x. So what I'm doing is I'm setting this guy as my function so that when I derive, and I'm trying to get f prime of x, my actual derivative function, I'll just derive shorthand over here by hand. F prime of x is equal to 6x squared. Now, let's do the work to make sure that this works. Okay? So old school wise, if I were to use Pascal's triangle, I have the x squared. So let me go ahead and do this, x plus h. So it's something cubed. And that's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This is x to the 0, x to the 1, x squared, and this is x cubed. So I know my coefficients are going to be 1, 3, 3, 1. Okay? So 1, 3, 3, 1. I also know that it's going to start with, let me go ahead and write this out, x cubed, x squared, x to the first, and x to the 0. X to the 0 is 1, so I'm not going to write x to the 0. Then, if I did, it would be right there, but I'm not going to write it because it's just 1. Then going backwards, it's going to be y cubed, not y, h cubed, then h squared, then h, and then again, h to the 0 is 1. I'm just going to leave it as 1, an understood 1. And then here, because of the fact that this is adding, they won't go positive, negative, positive, negative. They won't alternate like that. They'll just stay positive throughout. So all these are positive. So positive, positive, positive. With that 2 coefficient here is going to multiply by everything so that I have 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed and then minus this guy right here, minus 2x cubed all over h. Now I know it's been a while since we've done this, but the thing is we don't want to go back to it. We want to create this shortcut that'll bypass all this work that I'm showing you right now. Alright, so 2x cubed and 2x cubed, they cancel to 0 because you just add those. All these have h's, so that you know this will cancel, making that go away, making this go to h, and making this go to h squared. So that your final thing right before you apply the limit is 6x squared plus 6xh plus 2h squared. And if you apply the limit now, and you plug that in, you see that your answer is just going to be this leftover piece. F prime of x is equal to 6x squared. So what we did is we bypassed all this work simply by identifying what is my f of x, writing it down, taking the derivative, and being done with it. Okay? So if you need to rewind this video, you can. I'm going to clear this so that I can make room for part B. Okay, so part B says, again, definition of the derivative, you should see y2 minus y1 over h as h is approaching 0. So you should see that it's going to have that form so that you can quickly identify, well, what is my f of x? So let f of x be, and you don't think of a negative f of x. Don't think of that. It's saying minus f of x. So you're just defining what is f of x. So f of x is equal to cosine of 5x. Therefore, f prime of x is equal to negative sine of 5x times 5. So simplify it out. Most likely you'd write f prime of x is equal to negative 5 sine of 5x, and that would be your answer right there. Okay? So again, this bypasses all that work. Instead of doing it by hand, you could just do it straight like this with the shortcut. Your last problem. Okay, what's different about this one is that these two here had variables in it. This one, which is my f of x, I can't say let f of x equal 1/2. Because if there's no variable, despite whatever it is, whatever constant is there, you're always going to get f prime of x is equal to 0. Because the derivative constant is 0. And that's wrong. You're not going to do that when this is a constant. So what you have to do is, you have to look at not only your f of x term, but your f of x plus h. Okay? So here we go. This is like f of x plus h. And the way you're going to look at it as, this would be your f of x term. So your f of x term looks like it's the sine of pi over 6. But again, I cannot put it as a constant because the sine of pi over 6, okay, real quick review with the unit circle. Sine of pi over 6 is 321, so the sine is 1/2, okay? The sine would be a positive 1/2. We know that's not going to give us the right answer because if I take the derivative of yet another constant, I'm going to get 0. Again, it's not going to be 0. We need to make sure when we assign f of x that we have some kind of variable right there. Okay, so I'm going to see f of x plus h. Therefore, you should think this x lines up with that pi over 6. So I'm going to create it as sine of x. Okay? That's what this would be over here, only it's a little bit more specific because it has an actual value to it. Okay? So this is like f prime of x, or sorry, f of x is equal to sine of x, so that when you take the derivative, you're going to get cosine of x. Now, real quick, why is this 1/2? Well, we said f of x is sine of x, and that's what we borrowed from here as far as we know it had to be a variable of some sort right here. If you plug in, right now, pi over 6 right here, well, pi over 6 would yield a 1/2 because the sine of that is 1/2. So the reason why this was not a variable, is because of the fact is we have to create the variable and then plug in this pi over 6 right here so that sine of pi over 6 would be 1/2. And that's what this is representing as far as f of x. Okay, so if you need to rewind this video, by all means do so, pause it, whatever you need to, so that you understand how you're getting or how you have to set up this sine of x for f of x. Therefore, the derivative of that would be, the derivative is cosine of x, and therefore at the very end, what value are you going to plug in for this x right here? Well, you're going to plug in not 0. This is where it's a little bit different. You're not plugging it in. You're not plugging in 0. You're actually plugging in pi over 6. So this is looking for what is f prime at this numeric value. Because remember, this pi over 6 was never in the original problem a variable x. So it's not looking for the function's derivative function. It's looking for the function's derivative at a specific point. Very beginning, it's looking for f prime at pi over 6. That's what it's looking for. We had to create this f of x first because you always have to derive before you plug in your at value, your x value, input value. And then finally you'd go ahead and plug it in right now. So you would say f prime of pi over 6 is of course cosine of pi over 6. And then going to the unit circle real quick, we could say pi over 6 is going to be here, and the cosine should be root 3 over 2. Okay? Plugging in this into the calculator, you can see that it's going to be that as far as a limit, but chances are you're not going to use the calculator in order to get that. But real quick, let's go ahead and go to the calculator so you can check your answers at home or whenever you need to when you have problems like this. So we're going to get the limit function feature. We're going to say when h is approaching 0, and then we're going to go ahead and put that right there, the equation. So let's go ahead and do control divide, and we'll do the sine of pi over 6. So let me go ahead and get that fraction going. So pi over 6 and plus h. And then we're going to close the parentheses and do minus 1/2. So control divide 1 over 2. And then finally there at the very bottom we'll put an h. And when we press enter, we'll get the root 3 over 2, which was the answer that we got. So again, if you need to rewind this, by all means do so, because this is going to be very beneficial on the test when you go to use this shortcut rather than doing it the long way that I did from before. Alright, and I believe that yep, that's it for today. Alright.